Now you should be able to see the lecture. Yes. Okay. This is a nice part about the comfort zoom. A lecture is very hard to switch back and forth, but in the laptop, I can switch any screen that I want to show you. And also for the bonding theory, we learned about bonding, especially covalent bonding. It is very useful. It predicts the shape of molecule. And nowadays we have a coronavirus going on, and the people, scientists are trying to develop vaccines. In the first man-made computer-designed drug that is treat HIV, it is based on knowledge about the shape of molecule, which we are covering today. So the understand shape of molecule, it will help in the future the drug design or develop vaccines and so forth in the life science, and also can be used for design chemicals, the molecules that taste very particular taste. We can design molecules with a particular taste, pretty much based on shaped molecules. So it's very useful. And okay, next one. The bonding theory focuses on the Lewis bonding theory. Lewis is an American chemist. He proposed using the dots showing the valence electrons. And the chemical bonding are basically because valence electrons shared between the atoms. The last chapter, we discussed ionic bonding. Ionic bonding are the valence electrons transferred. Metals lose those valence electrons, and the nonmetal gain those electrons, and each one becomes charged, and then they attract. So that's ionic bonding. This chapter will focus on the sharing. The sharing electrons. If you remember the chapter 2, metals lose electron becomes noble gas configuration. Nonmetal gain electron become a noble gas. Because noble gas have 8 valence electrons. And that's what we call octet rule. So you can see the octet. Octet means 8. This chapter, when we construct Lewis structure, we'll focus on the structure that is following octet rule. Okay. There are a few exceptions, and we will not discuss. We just need to be aware. Just like people talk about, when there's a rule, there's exceptions. And so same with the chemistry. The octet rule, it is very useful, but it's not including all the situations. So because everyone want to be a noble gas, and that's become the octet rule. I'll give you examples how we draw the Lewis structures. And, so next, okay. The Lewis structure are basically show the valence electrons around the symbol of elements. And so here's the examples for the second row. This is second row elements. Start from lithium 1 dot, meaning 1 valence electrons. And beryllium have 2 valence, so 1 on each side. And so you can see all the way neon becomes 8, becomes neons or noble gas. That's the perfect octet. So when you talk about a neon have the 8 valence electrons around, it's a very stable structure. The other nonmetals, when they becomes noble gas, they will look around just like this with 8 dots, 8 valence electrons. The neon configuration, it is 2s2, 2p6. So the 2 for the s and 6 for the p, you add together, give it 8 electrons. And that's where the 8 dot come from, basically. So basically 2 dot come from the s, and there are the 6 dot come from the p orbitals. And that's second row. The third row, you can see is repeat because periodicity. The pattern repeats. Sodium 1 electrons and argon again become 8. They are just like in the second row. Okay, so that's dot without bonding. This is how each atom with valence electrons before they form bond. Okay, so let's take a look. When they form a covalent bond, they share electrons. The nonmetal tend to gain electrons to become octet, become noble gas. But if you look at the CO2 carbon dioxide have 1 carbon, 2 oxygens. Both are nonmetal. So if you're all nonmetal, each one try to gain electrons, then they'll fight. And actually for nonmetal to form bond, instead of a gain or lose, they share those valence electrons. And so that each one becomes 8. And they have many ways to share. And that's the interesting part of this chapter. So let's take a look. They share. So if you have the printout of the handout, you can write down these. I think I should write something. So, okay. By the way, if I write with pen, that looks not very good. But I try to write share. Yeah, this is not good handwriting. I will order a tablet that is dedicated for teaching. So very soon you'll see the much better handwriting from the tablet to show you to do the work and so forth. Okay, so share valence electrons. Share valence electrons. Okay. The nonmetal share electrons, they don't necessarily share in compounds. Even on their own, the nonmetal exists by themselves. They like to form bond to become noble gas. And so here are the start from hydrogen. The hydrogen atom cannot be existing by themselves because they have only 1 valence electron, not stable. So for hydrogen to become stable, they share. Okay, this is the 1 valence electron from 1 hydrogen. And the other hydrogen will share his single electron. So when you have this, look these two together. Now the helium, the hydrogen have 2 electrons. This hydrogen have 2 electrons. That's almost like a helium. It becomes stable by doing this. And same with this hydrogen. This hydrogen, I try to make them different. This hydrogen also have 2 electrons because shared, and also become a helium, become stable. So that's how the nonmetal atom share electrons and form like a noble gas. And so that's how the hydrogen form molecule. Later I'll show you the other elements, how they form the bond. Nitrogen also need to form bond between 2 nitrogen atoms. And same as fluorine, same way, iodine, same way. So we'll see how each one they form bond. Okay. And so those molecular, we call them molecular elements. There are 7 of them. 7 molecular elements. And you can see these are with the letters on with the symbols on each element. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And if you move the hydrogen here, actually it pretty much looks like a figure 7. So this is a figure 7. If you see my mouse, the figure 7. There are 7 elements that are diatomic, molecular, and the layout in the periodic table, it is looks like a figure 7. There's one way to memorize this. Did I mention this? I might mention this class. Anyway, it is. It goes have, no. I think the internet has a problem. You guys, can you hear me? Hello?
Yeah.
Yes.
Yes.
Okay, actually,
Yes.
there's
Yep.
a message from
Yes.
So okay, so far we're good.
Yes.
Okay, thank you. Oh, I lost mine. But to remember those 7 elements, it goes have, no, fear, of ice, cold, beer. So anyway, that's how you memorize the 7 elements. You try to remember. Yeah, let's make it easy, a fun way to memorize the 7 elements that have diatomic. Okay. In the gas chapter later, it becomes very important because the gas, how heavy each molecule is, depends on how many atoms each molecule. Okay, so molecular compounds. These are some molecular compounds. I think we probably just have enough time to go over the naming because I do have a meeting at 4 o'clock. So I have to stop at 4 o'clock. I can run like 10 more minutes. What happens? Okay, so these are molecular compounds. It looks like. Oh yeah, questions? Questions? Some of you have questions? Yeah, feel free to unmute yourself. You can ask questions.
Professor Wen,
Yes.
when will the exams? What I remembered you said the exams they're going to be on. Will it be online or will it be in the college?
Oh, any question about this? I will email to make it in print, not in the verbal, because right now I don't have answer yet. So
Okay.
sorry about that. Let's go on with the lecture, and I will ask, and I will let you know how the department, the college decide. So I have no answer for this. Okay, sorry about that. Let's get to next. Oh, naming compounds. The naming compounds. Any questions? How about you guys ask me in the next session or email, text me, okay? I will address each one by one. I make an announcement if the questions, very common questions. The molecular compound made of nonmetals. Binary means 2 nonmetals, only 2 nonmetals. For example, water and carbon dioxide. So these are binary, only 2 nonmetals. When we name those compounds, we use prefixes. The first nonmetal in the formula, we just call the full name, no change. Just call the name. Carbon, oxygen, fluorine, and so forth. Just full name. The second nonmetal, we change the end to IDE. And okay, because this is how we name the anions, come from the nonmetal. Oxide, for example, chloride, because there's a second one in the formula, we let them end with IDE. Okay. So this part is straightforward. But next one, the molecular compound, if to specify how many of atom in one molecule, we add a prefix. This prefix are started from the mono and di, tris, and so forth. So this is the general formula of how we name the compound. The start with the first, the element from the left, and for the second one, we're turning to IDE. We might add a prefix depending on how many of them in the formula. If there's only the first nonmetal, if first nonmetal only 1, we do not use mono. For example, the CO2, we call it carbon dioxide, and we do not call it monocarbon dioxide because the carbon is the first nonmetal in the formula. That's how we use the prefix. And so let's go to the prefix. Okay, these are often sound very familiar. So let's go over. Mono for one use mono, and 2 use di. 3 tri, the tripod. You know, camera has a tripod. 4 use tetra. Okay, very important. We don't use quad for 4. Tetra. And there's a game, if some of you probably play this game, a very ancient game, the Russian Tetris. Tetris basically 4 boxes and linked together, Tetris. Tetra 4. 5, we use penta. Pentagon, that's the unit, have 5 sides. And hex for 6. 7 use a hepta, and 8 use octa. And there's more, but I did not write down here because very rare compound has more than 8 in the binary compound. Okay? For the binary molecular compound. But for 9, we do have a nona. Okay, it's NO, NO, NA. Oh, actually, I cannot write here. Nona. Nona is. Oh, I didn't choose. Okay. For nona, we do have for 9. So when you have 9 elements, that's we use nona. And 10 we use deca. DECA. And actually those prefix related to the months. Oct is October, November, nona, December, deca. Okay. The number don't match because the Roman calendar started with March. And that's why the Roman calendar first month, it is the third month in the, what do you call it, Gregory calendar. Yeah. So anyway, related. Even September related to the hepta. Anyway, don't call it septa in the naming compound. That's very common. I mentioned this, and later students are using the septa for name 9, call 9. And so that's how we use the prefix. So most of you guys are probably familiar with the penta, hexa, and just need to memorize. Let's do some practice on this. Oh, there are some exceptions. And just because we call those compounds by their common name since thousands, 100 years ago. So we do not use those. All right. Water, we don't use the system name. And this we call ammonia, is ammonia. We could call this nitrogen trihydride, but we never do because always people call this ammonia. It's just easy. And hydrogen and sulfur form only one compound, so they only call this hydrogen sulfide. Otherwise, they will call this compound dihydrogen monosulfide. Okay, we never call it like this, but this is common name. All right, next, there's a few hydrogen chloride. Proper name should be hydrogen monochloride, but again, there's only one compound between chlorine and hydrogen, so just hydrogen chloride. In our test, I rarely ask you common names, so don't worry about the common names. Do I need to memorize a whole bunch of new compounds? Go by the system. I will test, need to know the naming by system. Mono, ditri, and so forth. So we don't call this carbon tetrahydride just because methane is a common name. Yeah, hydrogen peroxide. Oh, by the way, hydrogen peroxide is very good for antiviral. It's killed the or sanitizing. If you can buy this from 99-cent store, that's it's very important because alcohol seems like a short, and it's alcohol and hand sanitizer go short. Hydrogen peroxide is very good. Yeah, it's for disinfect. It kills virus. So it should name this dihydrogen dioxide, but again, we don't call that. It's just hydrogen peroxide. So disinfect. Okay, so let's practice some name. We have just a wrap up. We're just out of time. The first one, again, we don't use common name, so let's just practice use a system name. The first nonmetal, we just call the name, no change on the IDE. So the first one, we do not change the IDE. And this will be dinitrogen. I have the answer for that. This should be dinitrogen, and if there's 4 oxygen, we should use tetra, right? Use tetra. So tetra oxide. But oftentimes, when the A and O together, you can see many prefixes end with A. And when the A and next elements start with O, then the A and O together, we drop the A. If A and O together, we drop the A. In the end, it's just tetroxide without A. Okay. That's when you A and O together. A and O together, we drop the A. And for next one, the first one's boron. And boron, there's only one. First nonmetal, the left nonmetal. Okay, left-hand side nonmetal. If there's only one, we do not use mono. So for example, carbon dioxide, we just call it carbon dioxide. It's the same with this. This should be just boron for the first one. And the second nonmetal, there are three. The prefix for 3 is tri. So it's just simply boron trifluoride. Yeah, so basically that's how I named the molecular compound. And next, there's more practice, but I have to go fairly quick. Hope you guys can follow. I put those prefixes right here, so you can kind of follow the use those. Remember, we dropped A if A and O together. So the first one simply just sulfur tetroxide, no A. We don't have A here. And this one is 2-iodine. So we should add the diiodine. And here is very interesting. We do not drop the I. We keep both I. And by the way, this is another test. If anyone learned chemistry or not chemistry, you know, someone claimed he learned chemistry. How do you know? We ask him, name how to pronounce this word. This pronounced word will go diiodine. Okay. If you have not learned chemistry, you don't even know how to pronounce it because it's not English. It's not quite English. So diiodine. This is a di for 2 and iodine. Do not omit. Do not drop. But here the heptoxide, we dropped A. We don't show the A, just heptoxide. So basically, when to drop, you can see these are the ones, almost all of them. You can see that most of them have the end with A. If it's followed by the oxygen, oxide, then yes, you drop the A. Okay, feel free to ask questions. Okay, we're almost wrapping up the whole lecture. We are going to stop here. Next, this is a real compound, 4 phosphorus. So it'll go 4 use tetra. That'll be tetraphosphorus. And there are 10 oxygen. The prefix for 10, it is deca. So like a metric system have a deci, it means 1/10. Here the deca means 10. So here's the tetraphosphorus decoxide. So just it's pretty straightforward naming. It's much easier than the ionic compound, the one that I showed you the quiz. That is more thinking. You really think to do that quiz. All right, this is our last example. 3 carbon, so 3 use tri. This molecule is completely made up for practice. So it's just a tricarbon, 5 sulfur, so 5 use a penta. So tricarbon pentasulfide. So that's the today's lecture, and we have to stop here. I think most of you guys see the conference Zoom lecture. I think have a big advantage because we can have a schedule anytime, be more flexible and so forth.
Thank you so much.
Yeah. I think we'll have to wrap up today's class. And hopefully coming Wednesday we'll go over more material, so be prepared. Okay, the session's over, and thank you guys for coming. We have almost 40 people showed up. It's great, and let's keep in touch and post any questions on discussion. And I
The
see
session
you
is
guys.
recorded, right?
I think so. Yes, it's
Will
recorded.
will it be uploaded to Canvas?
Should be on the conference Zoom. I should be able to get a link soon, I think. I'll stop the recording.